All right, hi there. This is Rebecca. I'm one of your tutors graders for EAS212 with Evan Kristoff, winner 2018. I'm just going to be doing some little work throughs of different problems in the books. This one's it's going to be a three-parter. It's all going to have the same little image we see over here. This really simple three-membered truss. We got a pin at A, which we have a side view right over here of, which will be kind of the last part of the third part of this series. We'll look at that. Um, so yeah, pin at A and a roller at B. And this first part, question 40, is asking us to determine the average normal stress in each of the 20 millimeter diameter bars of the truss. And we're going to set that horizontal force P at uh, joint C to be equal to 40 kilonewtons. Let's pick a good color to get started. I like purple. All right. So step one, we're going to want to find the internal loadings in each bar. Hopefully you remember this from statics, but we're just going to do method of joints. Let's start with joint C because it's the one we have the information for. Um, we could go through the whole process of finding the support reactions at A and B, but we can actually do this whole problem without having to worry about those support reactions. You'll get really good at doing problems or seeing those kind of shortcuts in problems and saving time, which, especially for exams, it's really important to make sure you don't waste your time doing something like solving supports when you don't need to, or when you get into some of your upper division classes, there are times where you can't solve for the support reactions, but again, you don't need to, and it's kind of I had that on a question last quarter in structural analysis with Evan and threw a lot of people off because they went through the whole process of trying to solve these support reactions and lost, 10, 15 minutes on the exam. All right, so hopefully you remember. So average normal stress, this is going to be equal to our normal force, our axial force in the members. And again, this is a truss, so the members are really only subjected to those axial forces, which is the cool thing about truss systems. All right, so we got that N over A, and A is that cross-sectional area, which will be determined from that 20 millimeter diameter that they gave us. All right, and like I said, we're gonna, do the internal loadings of each member, starting with joint C. Gonna want to do a free body diagram. This will be our little joint C. Show that this will be our y-axis. This will be our x-axis. I'm just going to draw the positive directions. Can also do this whole thing. You want to make sure you state that even if you are using, this convention, it is good to write down so there's no confusion on your part or the grader's part. Make sure you get full credit. All right, there's that P, that 40 kilonewtons in the x direction. And then remember for trusses, the convention is to draw them in tension, so it's going away from C. So this is going to be F sub AC, and this will be the force for BC. Hopefully you notice we got one of those beautiful 3, 4, 5 triangles. It's going to make it really easy for us. Don't have to worry about solving for angles. Again, that's one of those shortcuts I was telling you about. You'll get really good at spotting after you've wasted time when you didn't need to. Oh, there's my purple. All right, so again, looking for a shortcut. We're going to start with solving our horizontal forces. If you can see, we'll only have one unknown. Make it super easy. Then if we jumped right into solving for the vertical forces, we have two. So we just have the horizontal BC axial force. Again, stating going to the right is positive, summing the forces equal to 0. It's not moving. All right, so we got the 40 kilonewtons in the positive direction, and again, because we drew all of them in tension, it'll be positive, only looking at the horizontal component of this force. Then we'll just go ahead and solve that. Hopefully you can do that simple algebra. Get that BC, 50 kilonewtons, and it's actually in compression. So when you solve it, you'll get a negative, stating that it's actually going this direction. I like to keep it a positive number and then write a C there for compression. But we'll keep it drawn like it's in tension, or keep, acting like it's in tension just for our own ease of things. Right, now that we got that, we can jump into solving for the vertical. Got negative AC, and then negative, again, just the horizontal, so the 3/5 FBC. And now, like you see, I wrote this like the FBC is going in this direction, which would be, or more so that the vertical direction is pointing down. But we know because the C that we're going to put in a negative value for this, making this a positive. So it'll actually become FAC is equal to the positive. There we go. Hopefully that makes sense. All right, and then solve for AC. We get 30 kilonewtons in tension, which is that positive sign convention. All right, now we can do it for B. We'll do that is a method of joints for joint B. A has too many unknowns. B has two unknowns, but only one in each direction. So we have the support BY, and then what we actually care about, which is the axial loaded member AB. And so we'll actually, if we want to be real quick about it, we won't even draw it, but it is good to just still. And if we don't need to, still take the time to draw joint B. Again, drawing it in tension. And then this is how I do it, when I first started out and I was taking these classes, I would, suddenly switch it back around, and then I couldn't remember if it was in tension or compression, or, I'd actually have put in a negative over here on the 50 kilonewtons, and that just all confused me. So in my drawings, I keep them in tension, and then when I'm writing down the actual magnitudes and directions of the force, I write compression or tension, and then when I'm substituting it back into like equation over here, when we get to the equilibrium equations, that's when um, we'll just draw the B support reaction at B. But as you can see, we don't care about solving for that. We just care about solving for this horizontal force in AB. Sure, we'll say that this is our positive, which means that this will be negative, and this will be negative, what is it, 4/5. I don't know why I blinked for a sec. FBC. And this is what I'm talking about, is we'll just keep that negative so you can make sure you just see that it's in compression, so I automatically add that negative back in, and then it'll cancel out, or come positive, and we'll get the force in AB as 40 kilonewtons in tension, which means we got a positive number. All right, so now we have all of those forces. We're going to want to go back to this original equation for our normal stress that's felt in those little cross sections, which is like if we were, cut it right here, you're seeing this. This will be its normal force, which is what we just found, all these little boxes. Change colors, just because I like colors. All right, so that would be if we cut it and we're looking at it, we have this cross-sectional area, and this will be A, which will be equal to pi over 4 times, switch this to meters just to make it easier. So we'll want to, when we're plugging stuff into here, have newtons over meter squared. One of those other tricks I've picked up just to avoid any mistakes with my units. Just keep it a certain convention, and then once I get to my final answer, change the order of magnitude how I see fit. All right, so 0.02 meters squared. Get the area is equal to 3.142 10 to the negative third meters squared. All right, so now we'll want to go and solve for BC. Normal stress will be FBC over A. They all have the same A. So this is what I'm talking about. 50 kilonewtons. But we'll change it to 50 times 10 to the third newtons. Then we'll get a pretty big number for pascals, and we'll just then from there switch it to megapascals. All right, and we'll do that for all of the other members. AC. Don't want to forget that meters there. But yeah, that's pretty much all we're doing. Sorry if I took a lot of extra steps, but I just want to make sure nobody's getting confused, because I've been doing this, a little bit longer than you guys. I don't want that to undermine or make it so I miss any steps here and confuse you. So I am trying to make sure I hit on everything, even if it seems simple to me, but hopefully it doesn't feel like a waste of time to you. So we get going, we can pick it up. Or you'll actually probably thank me later for taking my time on these. All right, so now we're going to go ahead and move to question 41, but it's the same truss system. But I will just start that as a new video.